So in the previous class, we have discussed about the discovery of electron and proton, and we have seen the cathode ray experiment and related to that one. So today we shall be going to study further, okay, properties of anodes. Okay. So today we shall be going to discuss. We have discussed this one discovery of three subatomic particles, and we have written the plum pudding model related to that one. We have also discussed. Okay, now today we shall be going to discuss the Bohr model. And first of all, we shall be going to discuss the Rutherford model because we have not discussed the Rutherford model. So just a minute, Rutherford model. Just a minute. Perfect. Now we shall be moving towards the Bohr model of atom. Okay. Sorry, Rutherford model of atom. So what does Rutherford? Rutherford did an experiment, and what does he do? Let me explain you that Rutherford did an experiment, and he find that when he take a gold. Let me show you first, then I'm going to explain you. First, let me explain you, and then I'm going to show you the video, and then we shall be going to write each and everything properly. Okay. So what I'm going to. So what does Rutherford do? Rutherford take a gold foil experiment. Let me explain you that it is a gold foil. Suppose, okay, this is a gold foil, and it is very thin. It is very thin, approximate 10 raised to the power minus 6 meter. Okay. So it is approximately 10 raised to the power minus 6 meter approx. It is very thin. And here we have alpha particle emitter. Okay, this is the alpha particle. Is a box that can emit the alpha particles and which is carrying there can be some substances that can radiate alpha particles. So this is the alpha particle emitter. Alpha particle alpha particle emitter. Okay, and then we pass. Okay, so what he when he passed these rays, what he find? And he was having the zinc sulfide screen below behind it. He is having a zinc sulfide screen here. And what is the property of zinc sulfide screen is that zinc sulfide screen is used to know where the atom is, the particle is going to strike. Okay. First of all, let me tell you that what is alpha particle. Alpha particle, alpha, alpha particle is doubly charged helium particles. Everybody please turn on your camera. Abza, Gauri, Shakrika, Alif. Everyone turn on your camera. The alpha particle is helium 2 positive particles. When helium atom loses its 2 electron, it becomes helium 2 positive, and that is called, means only the proton, yeah, nucleus of helium we can say. Like this is helium atom, helium atomic number is 2. So this is the nucleus of helium and it is having 2 electrons. Helium is noble gas, okay? So when you remove that electron, then helium will become only helium nucleus will be there, okay? And that is called helium 2 positive. So we can say that nucleus of helium is also called helium, okay? So helium is already small metal, but when we are saying that we are talking about its nucleus, so nucleus is already very, very small because nucleus is approximately uh, 1 lakh times smaller than the radius of the whole atom. Okay, 1 lakh times smaller. The radius of nucleus is always smaller. Okay, so what he said that he take the helium particles, and this is called alpha particle, alpha particle, alpha particle. Alpha particle do not have okay, means it has positive 2 charge. Now, when these alpha particle passes through it to zinc sulfide screen, we notice that most of the lines are straight. Means most of the lines are like they were going straight. Some of the rays get scatter. Okay, some of the rays deviate from their path. Like this was coming, this get scatter. This coming out, it get scatter. And 1 out of 12,000 rebound back to its original path. I mean, it does not go, it come back to its original path. Are you getting my point? What I'm saying? Most of the alpha particle goes straight without any deviation. Most of the alpha particle goes straight without any deviation. Some of the alpha particle get scattered or rebound to some angles. Or समझ आया? Are you getting my point? समझ आया? Hmm?
Can you explain once again?
Yeah, why not? Sure. That some, what was his observation? The first observation was that some of alpha particle get scattered. Okay. First observation that most of the alpha particle was straight, but going straight means without any deviation. So what was the actual reason behind it? Let me explain you. That is, suppose this is an atom. Okay. Let's suppose this is an atom. So the concept of nucleus was given by the Rutherford. That he said that since the most of the alpha particles are going straight without any deviation through the atoms, it means that atoms has a lot of empty space. Some of the alpha particle rebounds to small angles. So when they were coming closer to the nucleus, then alpha particle are positively charged. So when it come to the towards the nucleus and it is also positive, it is also positive, then it get diverted. It get diverted to its path. Okay, from it get diverted. So indicating that there is some positively charged particle present in the atoms or charged particle present in the atom through which the alpha particle get scattered. Means because of that, if because of that charge, the alpha particle is also positively charged. So when a particle will come closer to the another positively charged particle, then it will get diverted from its paths. So and 1 out of 12,000, some says 20,000. In many books, it is being written 20,000. 1 out of 20,000, the alpha particles rebound back to its original path 180 degree when it does not go and penetrate this one. So it means that when alpha particle is moving in the direction of nucleus, so it is not able to penetrate the nucleus. It is not, it means nucleus, it is the alpha particle was not able to penetrate that nucleus. Okay, means it is very
Yes,
hard.
sir.
That's it. It will not be able to penetrate that one. So it is indicating that there is something hard and dense present in the inside the atom through which a particle cannot penetrate. And he named it as nucleus. Got it? Got it?
Yes,
Or no?
yes.
Let me show you that what is the actual if I say that Rutherford experiment. वीडियो में हम समझेंगे रदर Okay, let me show you that this is the experiment that was given by Rutherford. And scattering experiment. So this is the atom. The nucleus was first was for the first metal means first was given by J. Thomson. First model was given by J. Thomson, and what he said that the whole metal is whole atom is made up of positively charged sphere, the brown part you can consider, and electrons are embedded inside it. Electrons are embedded inside it such that the total mass of the atom. Okay, but he was not able to explain the observations of Rutherford model, that why the some atoms are rebonding back, some of the particles are rebonding back, why they are moving. If it is positively charged sphere, then all must show same behavior. So here, when the particles were moving, so some of the particles, and he took the circular path. So this is the way that how he was able to know. Okay, let me explain you first this one. That is the video is visible to you now or not? Is the screen is visible?
Yes. Yes, sir.
Okay, so he took, this is the specialty of zinc sulfide screen. This is the specialty of zinc sulfide screen actually. Okay, and we'll say that this zinc sulfide screen, when the particle is moving and he is giving a straight line through this one, and these particles are generally striking here. If most of the particles are going straight and some are rebonding back, some are moving to small angles. So this was the observation that was done by him. Okay, and some of the alpha particles are coming back to its original path. So when he passed this one, he find this type of radiations. So indicating that most of the alpha particles are moving straight without any deviation. It means atoms has a lot of empty space. There's a lot of empty space. Alpha particles are helium 2 positive, means proton plus neutron present in the nucleus of 2 proton plus neutron, and it has mass 4. But charge is 2 because it has loosened 2 electrons. Okay. And gold foil is very, very small in size, very, very thin in size, sorry. And that gold foil is approximately 210 nanometer, which is very, very thin. Very, very thin. Because why he used gold? Because gold is the most malleable metal. Means you can means if simply we can say that gold is very much malleable. And he use alpha particle emitter. It is liberating out. So some of the alpha particles are moving and it is slit. It is slit which is having 2 slits, and only the particles which is going in this straight line will pass through this one. Slit means that it is going to have hole through which the alpha particles are moving and they will hit it. Now most of the alpha particles are coming back. You can see here that alpha particles are striking somewhere. Okay, you can see. So the alpha particles are moving in straight line, it means atoms is going to have a lot of empty space, but some are deflecting. You see that most of them are coming in the straight line, but some are deflected to small angle, and 1 out of 20,000 is rebonding back to its original path, indicating that there is some hard and dense substance present inside the atom through which alpha particle cannot penetrate. Okay, got it? You understood? Yes or no?
Yes. Yes, sir.
So this is the observations. So write down the first observation of this one. From here you can write also. Most of the alpha particles are coming back to its original path. Let me check. So you can check it like this way. That inside the gold foil, there are the atoms. Okay. If the alpha particles is moving through it, if it is strike on the positively charged, it get diverted. Not exactly to the positive charge. Okay. Done everyone? समझ आया सबको? You understood? So write down the observations here from here. Write down only the three part, that observation, this one. Write down please this one in the in your notebook.
So from where we have.
You the one which I have bold, this one. You have to write only that portion. Okay.
Okay.
Done.
No,
Write it fast.
no.
Hmm? Done, everyone?
Yeah.
Okay. So what was the observation of Rutherford model? So what was the observation? Let me check whether we have written this one in the notes, proper notes I have. What was the observation of Rutherford model? Just a minute. Give me a minute. Structure of atom. Uh, structure. Okay. So this was the observations of Rutherford model. You can write it. Okay. So here we have a spherical shape. Everyone please concentrate here. That what are the consequences? Okay. So this or what were the results of alpha particle experiment? So first you can write it from your own sides that what was the result of the first one. There's most of the alpha particles goes straight, indicate that you can write the first one here by your own. That now write down conclusions of Rutherford model. Conclusions of Rutherford model. What are the conclusions of Rutherford model? That most of the alpha particle, write it down. Most of the alpha particle, most of the alpha particles moves straight without deviations, indicating that atom has lot of empty space. That atom has empty space. Done?
No.
Do it, please. You done?
Just a minute.
Out of 12,000, one alpha particle rebound back to its original path, indicating that there is something hard and dense present in the atoms through which alpha particle can't penetrate. He named it as nucleus. Some alpha particle deflected at small angle, and it is there in some. Okay, there is something hard and dense present in the atom, and that is positively charged here. You done?
Yeah.
Everyone done? Noted?
Yes, sir. Yes.
Noted fast. Done? Noted
Yes.
everyone?
Yes, sir. Yeah.
Now write down the drawbacks of Rutherford model. So what does Rutherford? Rutherford said that. What was the actual plans of Rutherford? And what does he said actually? After giving this experiment, Rutherford gave his own model that for the atoms. And what he said that the nucleus is positively charged in the atom, and the whole mass of the atom is concentrated in the nucleus. Means the whole mass of the atom is concentrated in the nucleus, and we can say here, okay. And he said that electrons revolve around the nucleus, that he in an orbit. But the concept of orbit was declined that by the other scientists, because if an element, if a charged particle revolve around another charged particle, it will not keep its energy constant. It will continuously radiate its energy and will continuously lose. And when it lose, it will take no time for the nucleus to collapse. Sorry, for the electron to collapse with the nucleus. So what he said actually, he said simply that electrons are negatively charged. Okay, electrons are negatively charged, and I can do this. So it will take no time for the nucleus to collapse. Got it? And the electron will collapse, and the electron will collapse with the nucleus, and the whole atom will get destroyed. Got it? समझ आया? Understood?
Can I explain?
Yeah, why not? Sure. What he said that he first said that the atom contain a positively charged nucleus, and the positively charged nucleus is very small as compared to the size of atom, because most of the alpha particles were going straight, indicating that atoms is lot of space, and 1 out of 12,000 is rebonding back. It means the positively charged particle from which the alpha particle cannot penetrate, that particle, that substance is very small as comparison to the whole size of the atom. So we can say here that this nucleus is positively charged and it is very hard and dense. The whole mass of the nucleus is concentrated in the nucleus. Sorry, whole mass of the atom is concentrated in the nucleus, and the electrons revolve around it. Electrons is revolving around it like the planets revolve around the sun. Okay. But this theory was proved wrong, or we can say that since planets are not a charged particle and they are moving, okay, they are revolving around the sun in a fixed orbit. But the fixed orbit concept cannot be used for the electrons, because if the electrons revolve around the nucleus, then they will continuously radiate its energy. It was given by Maxwell. And according to the Maxwell theory of electromagnetic inductions, electromagnetic wave, sorry, that when a charged particle revolve around another charged particle, it continuously radiates its energy. It will continuously lose its energy. An electron is going to have very small energy. So for an electron, it will take only 1 upon 100 crore part of a second. Means 1/100th crore part. Just to divide the time segment of, means it will take no time. Instantly, the electron will collapse with the nucleus and the atom will become unstable. But in real life, it does not happen. Are you getting my point? That
So, but there are,
who proved this statement wrong? Maxwell. Maxwell said that if you are saying, Rutherford is saying that charged particle electrons revolve around the nucleus. So according to the theory of electromagnetic waves, that charged particle must continuously lose its energy. Okay. And when it lose its energy, though, it will collapse with the nucleus and will make an atoms unstable, but it does not happen in real life. Okay. Getting my point? You understood?
so
Am
sir,
I right?
even Maxwell is wrong.
Hmm?
So even Maxwell is wrong.
Even Maxwell?
Is wrong.
Yeah, Maxwell is wrong, because atomic theory and the normal theory, like there are two types of physics. One is Newtonian physics, another one is modern physics, or we can say that that in which we are just going to study about the atoms and molecules. So like we say that energy can neither be created nor destroyed. Okay, but this law is applicable for the macroscopic things. Okay, uh,
Yes, sir.
so we are using that we can destroy the mass, we can convert mass into energy in the nuclear reactions. So some laws are applicable for the Newtonian physics, for the substances which are having macro, but for nucleus electrons, these laws are not applicable. So nuclear physics is not means the laws of nuclear physics is not applicable for the Newtonian physics. Okay, got it? So
Yes,
even
sir.
because now we know that electron revolve in the particular orbit around the nucleus, but that was he was not able to explain that. Okay,
Yes, sir.
even even though one more thing here is that he was not able to explain. According to this rule, when we see the emission spectrum of hydrogen, because when it is releasing its energy, when hydrogen electrons will release in energy, we see that the emission is not continuous. Means like, for example, if electron is here, if it is continuously revolving and making a spiral path, so it will continuously radiate its energy with it. Okay, continuously. But we say that discontinuous energy is being released. We see that like hydrogen spectrum is like this. The energy is not continuously releasing. Okay. Sometime releasing, then not releasing, then releasing, not releasing. It is showing discontinuous release of energy. So if the electron is revolving around the nucleus and it is radiating its energy, so it must show continuous path of releasing energy, but it is not showing continuous path. It means it means it means that means Rutherford was not able to explain this one. That's why there's a discontinuous spectrum if it is releasing, and Maxwell too also. So we'll say that because of these assumption that electron, if it is revolving electrons is radiating its energy, so it must show the continuous pattern. Okay, but it is not showing continuous pattern. So emission spectrum. So because of that reason, that model of atom was not considered as that the actual model that so in real life. So write down the drawbacks. First of all, you have to write the what does about the Rutherford model, that what Rutherford said actually. Drawback of J.J. Thomson. So on the basis of Rutherford proposed a model of an atom, write down the feature that there is a positively charged nucleus inside the atom, and nearly all the mass resides inside a proton. So you can write it here. Okay, so please note it down. You done? Noted? You done?
Yes.
Write down the drawbacks of Rutherford models. Just done. Okay, drawbacks. Write down the drawbacks of Write down the drawbacks of Rutherford model, please. You done?
Um,
Done? Okay. So according to the Rutherford models, electron revolve around the nucleus in well-defined orbit, but electrons being charged particle will lose their energy and finally will fall into the nucleus. 10⁻⁹ Okay. This is the major drawbacks of Rutherford model, which was explained by. So that we're going to study. So can you tell me that what are the drawbacks of Rutherford model? Can anybody in the class can answer me that what is the drawback of Rutherford model? In English or Hindi, you can explain. What are the Chagrika? Can you tell me that what are the drawbacks of Rutherford model? Can you explain? Hmm.
So he basically explained, he failed to explain the stability of an atom.
But yeah, stability of the atom. What kind of stability?
Like he said that basically the electrons which are revolving constantly, they would lose energy by emitting radiation.
Hmm.
So this would lead to the electrons
The nucleus.
disturbing the nucleus, making the atom unstable.
Very good. Proud of you. But in real life, it does not happen. So, okay. Got it?
Yes, so
Okay. Next. Can you tell me? Okay. So, can you tell me that what are the observations of Rutherford model? Observations of Rutherford models. What does Rutherford experiment? What Rutherford experiment? Yeah, in Rutherford experiment, what does he observe? What does he observe? He said that sorry, most of the particle pass straight, indicating that atoms has lot of empty space. Second is that uh, out of means some of the alpha particles get deflected to small angles, indicating that there is some charged particles present inside the atom through which alpha particle get deflected. And lastly, 1 out of 12,000 particles of alpha particles get deflected back to its original path, indicating that there is something hard and dense substance present inside the atom, which he called nucleus later. The discovery of nucleus was given by done by Rutherford. Okay, got it? So through which alpha particle cannot penetrate, and that is because that is very hard and dense, and because of that, alpha particles rebound back to its original path. Okay, got it? You understood? Understood? Yes or no?
yeah. Yes, so
Okay. So that's all for today. We'll meet you next one. Thank you for coming.
thank you so